Hello everyone, welcome back to my channel. My name is Dr. Yogita Bisht, and in today's video we will summarize all the formulas that we have studied in this series of mole concept. So I will start with the number of moles and then we'll move to the formula for the concentration calculation. These concentration we express in terms of molarity, normality, molality and mole fraction. If you want to watch the detailed video, I will provide the link for these videos. Alright, so let's just start with the first formula, that is how to calculate number of moles. Number of moles are represented by small n, and there are different formulas for the calculation of these depending upon the given data. Okay, so when the given data is, for example, when mass is given, then the formula that you are going to use is number of moles is given by given mass divided by molar mass. Molar or atomic mass. Alright. Similarly, another formula that you can use to calculate the number of moles is when number of particles are given. Here by particle I mean the number of atoms or the number of molecules. When number of atoms or molecules are given, then the formula that you are going to use is n is given by number of particles divided by Avogadro number. Here, as you all know, Avogadro number is given by 6.023 10 raised to power 23. Okay. Third, when volume is given. Okay. So in that case, number of moles are given by volume in liter, of course, divided by 22.4 liter. Okay, this is also in liter, so that the liter get cancelled out. Why we have taken 22.4 only, and like how to put the values here and calculate all this number of moles, if you want to watch those I have already made a detailed video for the same. You can watch that. All right. So one thing that you need to keep in mind while using this formula is volume should be in liter. Secondly, it should be at STP. STP means standard temperature and pressure. That means the data that being provided to you, for that the temperature should be 273 Kelvin and pressure should be 1 atmospheric pressure. Okay. Sometime instead of liter they will also write decimeter cube. So two are the same thing. It doesn't matter. But if it is in given centimeter cube or maybe in ml, then you have to convert into liter. Okay. So these are the three formulas that you can use to calculate the number of moles. Alright. And sometime what will happen, some other value number of moles will be given to you and you will be asked to calculate the given mass. So my tip to you would be like write these simple formulas in a sheet and then start applying the given data, and definitely you will be able to answer this question easily. Alright. Then another formula that is important for the concentration is molarity formula. Molarity is represented by capital M and its formula is number of moles of solute divided by volume of the solution in liter. Okay, so this is the formula. Now you can see why these formulas where we studied how to calculate the number of moles are important, because in rest of the formula you will see that you are repeatedly using the number of moles formula again and again. All right, then we have another formula for normality, which is represented by capital N, and its formula is number of gram equivalent divided by volume of the solution in liter. Okay, so how to calculate the number of gram equivalent from number of moles, because till now we have studied only three formulas with the help of which we can calculate the number of moles. But what about the number of gram equivalent? So we have an equation, or rather I would say a relation between the number of moles and the gram equivalent. So number of gram equivalent is given by number of moles multiplied by n factor, which is also called acidity or basicity of the acid and the bases. Okay, how to calculate the n factor, what is n factor, all this information you can get it in the previous videos. All right, so this is the relation. So once you know the number of moles, you can just divide it by you can just multiply it by n factor and you will get the number of the gram equivalent. We also have a relation between the molarity and the normality, which is also important. Normality is given by molarity multiplied by n factor. Okay, so this is also a very important relation you should remember. Another important relation that we use multiple times is N1V1 is equals to N2 V2. One represent the previous condition and two represent the new condition. For example, you dilute something, right? So one represent the condition before dilution, two represent the condition after dilution. So you can be asked like, if this is the solution with this volume, we add this much volume to this, what is the new normality? Okay. In a similar line, we can also write it as n factor 1 m1 v1 is equals to n factor 2 m2 v2. These two are the similar formulas. We normally don't use m1 v1 is equals to m2 v2 for the calculation. Alright, the next formula that we are going to talk about is molality. Molality is represented by small m and its formula is number of moles of solute divided by mass of the solvent in kg. Okay, so you can see a difference between the molarity, normality and the molality formula here. That in molarity and normality we talked about the volume of the solution. Here in the denominator you can see in both the ways we have the volume of the solution, whereas in molality we talk about the mass of the solvent. Okay, not the volume, rather mass, and that too of solvent rather than the solute. I hope you know what is a solute and solvent. So solute plus solvent give you solution. Okay, so in molality we use the solvent rather than the solute. And why we are talking about it in terms of volume rather than in mass rather than volume, all these things I have already explained in the previous video. And in fact, why we prefer sometime molality rather than the normality has also been provided in the explained in the previous video. I will highly suggest you to go through those videos. So this video is just a short recap of all those things. Okay. Another thing that you need to keep in mind while solving this question related to molality is formula for the density. How to calculate the mass of the solvent. So we know that you will be provided numerical, you will be provided with the density. So we know that density is mass upon volume. Okay, so in numerical you will be provided with the density and also with the volume, so you can easily calculate the mass, that is density multiplied by volume. Most of the time in case of molality you are provided with the density and volume only, so you just have to multiply these two and put it here. And sometimes you will get this in gram, you need to convert into kg, so these conversions are also very important. These has also been covered in the previous videos. Okay, so the last formula that we are going to write is mole fraction. Mole fraction is represented by xi. So just consider a system where we have component A and component B, and we want to express the concentration of the each terms. Then in that case we use the term mole fraction. So if I have to find the mole fraction of component A, that will be given by number of moles of A divided by number of moles of A plus number of moles of B. Then similarly, if we have to find the mole fraction of component B, that will be given by number of moles of B divided by number of moles of A plus number of moles of B. Alright, so these were the important formula that you need to recall to solve any question based on the mole fraction, mole, number of moles and the concentration. Okay, so you can use it as a cheat sheet. So just try to the last minute recall of all the formulas, so you can use that this sheet for that purpose as well. All right, so thank you so much. I'll see you in the next video.